Hello, welcome to another Henstitute help session. In this one, we're going to take a look at problem number 10. So problem number 10 really, it's not anything too complicated. It just has lots of little parts, and you're kind of doing the same thing over and over again. So you have baseball player A. They bunt the ball in such a way that they give it an initial velocity in the horizontal direction of 1.9 meters per second. It's hit 1.2 meters above the ground, and then it hits the ground. And specifically, it says player B wants to duplicate this bunt so that they give it a certain horizontal velocity and have it go the same horizontal distance. So this is actually key here. But they are going to hit it from 1.5 meters above the ground. So we're trying to figure out what their initial Vx should be. So I'm going to start over here with player A. So the idea with player A is they're going to hit the baseball. So here's my baseball. They're going to hit it with a horizontal velocity. I'll call it Vxa of 1.9 meters per second. They are hitting it 1.2 meters above the ground. So from here down to the ground is 1.2 meters. I'm actually going to put a minus sign on here and write this as y. In other words, the ball is going to fall 1.2 meters. So the ball is going to go like this and hit the ground. Let's erase a little bit of that. It's not going to go through the ground. So just hit the ground. We would like to know is what this x is, because this x is the same as for player B. Well, to find this x, I have to take Vx of A and multiply it by time of A. Now, the time of A can be found using my y information. So this is kind of a typical one that we took this lovely equation that y equals biy t minus 1/2 g t squared. Since this is 0, you can rearrange this, and the time it takes to hit the ground, if it has an initial vertical velocity of 0, is minus 2y over g. So if I want the time for A, I just have to use the y for A. So the idea of this one is we already know the Vx. This number, it can go in here. We're going to have to calculate this time. It can go in there. That's going to find the x. That x is going to carry over to player B. So let's pick a different color for player B. Let's make them orange. So here's player B over here. Player B wants it to travel the same x distance so that these x's are the same, but it's going to hit this baseball from a higher point. We don't know its Vx. That's what we're going to try to find. So I'm going to be taking x and dividing by the time for player B. So it starts out, YB is, where is it? 1.5 meters above the ground. So it's going to fall 1.5 meters. So it's going to go and hit the ground like this. This x is the same as this x. So these two x's are the same. So I have that value already. I just don't know the time for B. Well, here's the cool part. You can actually find the time for B by taking the square root of minus 2 times YB over gravity. And we know YB, and then I can plug that in. So it's got just a whole bunch of stuff, but it's really just two equations. You're finding time with these t equal to square root equations, and then you're finding velocities or displacements with the fact that Vx equals x over t. As long as you kind of do that and realize this displacement is the same, you should be set. I hope this is a little bit of help on horizontal projectile problem number 10. Enjoy!